Saoirse ran two different marathons, the Windy Marathon and the Sunny Marathon. The table below gives some details on the finishing times for the two marathons. For each marathon, the finishing times of the runners are positioned straight away there. You're thinking, oh, used to that if you keep practice on her finishing time. Saoirse came 5,265th in the Windy Marathon. So exactly 5,264 of the 6,000 runners had a finishing time that were less than Saoirse's. Saoirse's finishing time for both marathons was the same. Okay, so her finishing time was the same, but the means are going to be different. The standard deviations are going to be different. It's a different set of runners, different amounts of runners as well. But what we do know is that her finishing time is the same. So use this fact and the details in the table to estimate Saoirse's position in the Sunny Marathon. Show all of your working out. Okay, so what we really need to do is we need to find her time. So we need to find her time in the Windy Marathon, because if we do that, then her time in the Sunny one is the same. So we have a position, we know how many runners, we know the standard deviation, and we know the mean, but what we don't know is her time. So the first thing is, if she came 5,265th out of 6,000, straight away we can write down what that would be as a percentage or a decimal. So let's see what that is. Okay, so this is our decimal, 6.8, 775. Now, of course, again, if it's a four-digit number, a percentage or a decimal, we find it on page 36, 37. Remember that this is not a z-score now. This is our decimal or our percentage. It's our probability. Okay, it's all of those things, because probability can be written as a percentage or a decimal. So it's written as a decimal, basically. So let's see if we can find the corresponding z-score for that decimal. So within the table on page 36, 37, I'm looking for 0.8775 or the closest I can get. So 0.8770, 0.8790. Okay, so I'm going to go with the z-score of the one that's closest, really, is the 1.16. Now, if that's my z-score, so again, this normal distribution, it comes back to the standardizing formula. So usually it's x. Now, x in this case is her time. Now, we don't know her time, of course. So her time minus the average time in the Windy Marathon is 254, all over the standard deviation, which is 38. And we let it equal to her z-score. And in this case, of course, we know the z-score. Normally, we're calculating this to get the z-score, but in this case, we have it. So we cross-multiply. So cross-multiplying here, I have 1.16 times 38. So that is 44.08. And then we add on our 254 when we move it over. So x is equal to 298.08. Now, that's her time. That's actually the time that she got in that race. Now, what we know is the time in the first race ends up exactly the same as her time in the second race. So when we go to look at the second race, if we use the same formula, the standardization formula, we can fill in the x this time because we actually know the time, because remember, we're told in the question the times are the same. So there I have my time. I take away my average, in this case 247, because I'm doing the Sunny Marathon, over 29. And that should give me a z-score. So let's do that now. 247, divide that by 29. So I'm getting 1.7613, etc. Now, that, remember, is the z-score for the second race. So now, to get her position, I'm going to have to change that into a decimal so that I can change that back into a position. So I'm basically, I suppose I did it this way, and now I'm doing it the opposite way. I've got her time and I'm going back. So let's check the Z score. Now remember the Z score, page 36, 37 is where it's written in bold. We can only do up to 2 decimal places for a Z score, so we're just going to have to use the 1.76. So I'm looking for 1.7, and then I read across my line and I find 1.76. So that's 0.9608. Again, on page 37, finding 1.7 and then reading across to the 6. Now, that is my probability. It's a decimal. You could change it as a percentage into a percentage. But in this particular question, we're interested in her position. So essentially, she's in really, I suppose you could say, the 96th, the 96% position. And that sounds a bit strange, but what I mean by that really is you're going to work out her position by multiplying it by 2000, because that will tell you essentially what percentage of runners were ahead of her or behind her. So when I multiply it, I get an answer of 1921.6. So essentially what we found out is that she was in the 1922nd position. And that makes sense because we're essentially saying there's about 96% people ahead of her. So she hasn't done very well here. We expect her to be closer to the 2000, given the fact that there's 96% people ahead of her. So anyway, that's our answer. And yep, that's that question done.